All right, so this is chapter 3.2. I'm going to talk about other ways that you can see whether or not something's a function and then how you read actually some of these functions. So we'll start off with the vertical line test. Now we've kind of talked about this before, but basically the vertical line test is a test that helps us to visually look at a graph and know whether or not it's a function. So the theorem says that it is a set of all points in the xy plane in the graph, or is the graph of a function if and only if every vertical line intersects the graph in exactly one point. So exactly one point. So let's actually look at some of these and get an idea of kind of what we're talking about. So we got two graphs here. Let's start with the first one. And if we notice, no matter where we are on this graph, we are always only going to be able to draw a line that hits through one point, no matter where we are. So we know then that this is a function. So yes, this is a function. Now it asks us for the domain and the range. Well, we know then the domain, there is no restrictions here. So the domain is negative infinity to positive infinity, because we know that as we look around, there are no restrictions as to what x could be. Now that's our domain. Now our range is a little different, because we know if we look at our graph, well, the lowest value of y that we have is a 0. So in this case, it would be from 0, and if you notice, it continues going all the way up, so it's 0 to infinity. So if we look at our second graph here, this is a graph of a cubic function here, and we know following that vertical line test here again, there is no place that we could actually draw a line that was going to hit more than one point, a vertical line. So we know then that this is a function, and then our domain, if we look at all the possible values of x, is going to be negative infinity to positive infinity, and our range is also negative infinity to positive infinity. Because we're looking down here, this ends in an arrow, it keeps going down, and this one keeps going up. So we know that we are dealing with that. So now let's look at these two. So if we look at this one, this first one on the right, we know, oh, if I draw a vertical line, I'm going to hit that graph in 2 points. I can draw it several different places, and I'm going to hit that graph in 2 points. So this is not a function. So no, not a function. All right, now let's get that domain and that range. So if we look at the domain, well, we know that our graph is not showing us anything that's less than 0. So we know our domain is starting at 0 and it's going all the way up to positive infinity. And if we look at our range, well, if we look at the arrows, this arrow is definitely pointing up and increasing. This arrow is definitely pointing down and decreasing. So we know then that this is going to be a negative infinity to positive infinity. Now if we look at this one, here again, we can draw a vertical line and it's going to hit in more than one spot, several different places. So we know that this is not a function. But we do know that we can do the domain and the range. So if we're looking at our domain, well, the smallest value of x that we can have is -3, and the largest is a +3. So we know our domain is -3 to +3. And our range then starts at we start at the bottom here, -3 to +3 as well. So we know that's basically how we would use that vertical line test. Okay, so let's actually start reading some things and give you a little bit of notation. This is a little confusing up here, but basically what this is telling you is that if we have a point x and y on the graph, then we know that we can also write the function like this, y equals f of x, so that we can use this function notation if we know it's a function. So, and then it's also telling us that, for example, if I have the point 1, 9 is on the graph, then f of 1, that's our x, is going to equal 9. So it's just a way of kind of showing you notation. And if I have f of 5 equals 4, then I know that I also have the point, our x is 5, and our y is 4. So we know we have the point 5, 4 is going to be on the graph. So if I look at our information here, kind of so we can see more of these. If I look at my information here, it's asking me what is f of 0, f of 3 pi over 2, f of 3x. So what that's saying is that what is the value of y when x is 0, 3 over 2, and 3 pi. So let's go to our graph here. If we look at this, we know then that f of 0, or when x is 0, that the y value is 4. If we look at our point right here. So then we know that f of 0 is 4. So then f of 3 pi over 2. So remember that's saying what is y when x is 3 pi over 2? So what is y when x is 3 pi over 2? So we're looking at this point right here. 3 pi over 2. Well, what is y? Y is 0. So f of 3 pi over 2 is equal to 0. And then if I look at our last one here, f of 3 pi, well, f of 3 pi. So that's 3 pi when x is 3 pi. What do I know? Y is 4. So f of 3 pi is 4. So let's look at the domain of our function. We know that the domain of our function is the set of all the x values, possible x values. So if we look at this, we know that our possible x, we've got smallest x is there at 4, and then it's going to continue all the way down to 4 pi. Now in both of these cases, those are closed dots, so we know that it can be the value. So we would do a bracket 0 to 4 pi. All right, so let's look at our next problem. All right, so what is the range of the function? So remember the range is going to be our y values. So if we look at our y values, here we know that the smallest y value that we're going to get is -4, and the highest y value we're going to get is a +4. So we know that the range then of our function is going to be -4 to +4. And we know in both cases that it can actually be that value. So now list the intercepts. So we have two types of intercepts. We have x-intercepts and we have y-intercepts. So our x-intercepts are where it hits the x-axis, and our y-intercepts are where it crosses the y-axis. So let's do our y-intercepts first because there's only one of them. So if we look at our graph here, we know that the only place that it's crossing the y-axis is right there. So we know then that our y-intercept is going to be the point 0, 4. Okay, now our x-intercept is where it crosses the x-axis. So we know then that it's crossing the x-axis right here, right here, right here, and right here. So we know we have 4 different values in which it crosses the x-axis. So that means we have 4 x-intercepts. So those would be at pi over 2, (3 pi over 2), 5 pi over 2, and finally 7 pi over 2. So in each one of those cases, that's where it's crossing that x-axis. All right, so let's look at the next question. How often does the line y equals 2 intersect the graph? All right, so we need to figure out where that line y equals 2 is. So where does y equal 2? Well, y equals 2 anywhere along that line right there. So anywhere along that line. So how many times does it actually cross the y-axis? Well, it's going to cross it 1 right here, 2 right there, 3 right there, and 4 right there. So how many times does it actually cross the y-axis? How many times does it actually intersect the graph? Well, it's going to intersect the graph 4 times. All right, for what value of x is f of x 4? So what this is asking you right here is that what value of x gives us a y of 4? So let's go back up to the graph. What value of x gives us a y of 4? Well, there's a couple different ones. We've got what value of x gives us a y of 4? Well, y is 4 right here, y is 4 right here, and y is 4 right here. So what value of x gives us a 4? 0, 2 pi, and 4 pi. All right, let's go to the next one. For what values of x is f of x greater than 0? We are looking for any place on the graph where y is greater than 0. So y has to be greater than 0. So y needs to be above the x-axis. So if we're looking, it's right here. Y is also greater than 0 all right there. And y is also greater than 0 all up here. So we know that each one of those sections y is going to be greater than 0. So when we're actually writing our answer, it's going to look almost like those domains that we were kind of using before. So it's going to go from it can be 0. It goes all the way to pi over 2, but it cannot be pi over 2 because if it's pi over 2, then it equals 0. And it has to be greater than 0. So then it's going to pick back up at 3 pi over 2 and continue to move all the way till not 0. I'm not sure what I was writing there. Let me erase that. It's going to continue all the way over until we get to 5 pi over 2. And then again, we know that it cannot be 5 pi over 2. It's going to stop and it's going to pick back up at 7 pi over 2. And it's going to run all the way until we get to 4 pi. Now when we get to 4 pi, it can be 4 pi because 4 pi gives us an answer of 4, which is a value that is greater than 0. So we know then that we're going to get that's going to be every value that gives us every x value that gives us y greater than 0. So that was our last question, so we'll go ahead and stop here. You'll have a good evening.